object stays at S speed and direction, let's say force acts upon it. So Isaac Newton's second law of motion.
The more mass something has, the more effort it takes to accelerate it.
Third law of motion.
For every action force, there is an equal and opposite reaction force.
And the ball has stored energy, which is called potential energy. And when he flicks it, it changes into kinetic energy. It's not supposed to do that.
Which is the energy of motion. You see motion as in when we hit this. And now, like when you hit the Nemo for 500 points. Tomorrow. For 500 points. And when you hit the Dory for 750. Or the Nemo for 1,000 points.
Or the ramp to the Nemo
or the
for
ramp
1,500.
Or
the ramp over the Nemo to the Dorothy for 6 million points. And that's our video.
This is our pinball machine based off the TV show The Vampire Diaries. When it bounces off the launch pad and if it goes up the ramp, it earns 100 points. If it goes through the cure, it earns 50 points. And if it goes and bounces off the tombstones, it earns 25 points. And if it goes in the Ascendance rings, it is 500 points.
Newton's first law of motion. An object at rest stays at rest unless a force acts on it. A moving object moves at the same speed and in the same direction unless a force acts on it. When the ping pong ball is in the launch pad, it is at rest. It stays at rest until the flipper hits it to start the game. It is also the energy conservation because it starts at potential energy, but then when the flipper hits it, it goes into kinetic until it starts at rest again, which also relates to Newton's first law.
Newton's second law. The power of the force and the object's mass affects how the object accelerates. The ping pong ball has less mass so that it can accelerate more when it hits the flippers or anything else it might hit.
Newton's third law. For every action force, there is an equal and opposite reaction force. When the ping pong ball bumps into a tombstone or the sides, they push back with the reaction force. This describes Newton's third law.
This pinball machine represents Newton's first law by how the ball is at rest in the starting chute. And then it's propelled forward by the force that we make created with our hands.
The second law applies to this pinball machine as the player uses the bumper to hit the ball up the ramp, which causes the ball to accelerate.
This machine represents the third law where the bumper collides and pushes against the ball and the ball pushes back.
This pinball machine also represents energy conservation by how the ball rests in the starting chute and then its energy changes from potential to kinetic whenever we flick it up the ramp. Then as the ball goes through the drain, its energy changes back to potential.